Hi, today we are going to talk about problems related to motion of bodies in a straight line. Basic basic information about displacement, velocity, acceleration, equations of motion to do the problems. Velocity, we know, rate of change of displacement. Suppose two bodies are moving at two different speeds. Calculate the average means average velocity. Velocity of first body plus velocity of second body by 2. That's all basic thing. Velocity is displacement by time, speed is distance by time. Velocity is a vector quantity, speed is a scalar quantity. Acceleration is rate of change of displacement. A is equal to dv by dt. Or A is equal to V minus U by T. V minus U by T. Anything you can see. Three equations of motion you know. V is equal to U plus AT. S is equal to UT plus half AT square. V square is equal to U square plus 2AS. V is equal to U plus AT. S is equal to UT plus half AT square. V square is equal to U square plus 2AS. So these are the three equations. So keep this in mind. We'll go to the problems. Sometimes we have to calculate the velocity. Sometimes we have to calculate the acceleration, average speed, average acceleration, displacement of body. What is the time taken? Vertically moving upward or downward. So in the case of vertical motion, A is replaced by G. A body is thrown in this direction. When the body is thrown in this direction means it is going against the gravity. So A is replaced by minus G. When the body is coming down, it is attracted by gravitation force. So A is equal to plus G. So depending upon the case, we have to use. Okay. We'll go to the problems. On a 60-kilometer track, a train travels first 30 kilometer with a uniform speed of 30 kilometer per hour. How fast must the train travel next 30 kilometer so as to average 40 kilometer per hour for the entire trip? First problem. Velocity is rate of change of displacement, that is displacement by time. Average velocity. First displacement S1, next displacement S2 by time T. S1 plus S2. Time they have not given. So time is equal to distance by velocity. S1 by V1 by S2 by V. Correct? What are the data given? Here, first 30 kilometer, next 30 kilometer. So I can write S1 is equal to S2 is equal to 2S. Here S1 and S2 both are same. Take it out. 1 by V1 plus 1 by V2. S and S cancels. So simplify 2 by V1 plus V2 by V1 V2. So average velocity is 2 V1 V2 by V1 plus V2. Basic part. Average velocity is given. What is the value? 40 kilometer per hour. 2 into V1, that is 30 kilometer. V2 we have to calculate. So V1 is 30 plus V2. Cross multiply. 1200 plus 40 V2 is equal to 60 V2. 20 V2 is equal to 1200. 0 cancels. V2 is equal to 60 kilometer per hour. First, the body is moving with 30 kilometer per hour. Average speed is 40 kilometer per hour given. Therefore, what is the velocity of the next 30 kilometer? That is the question. That answer is 60 kilometer per hour. V2 value. Okay. Next, second problem. A body travels the first half of the total distance with velocity V1 and second half with the velocity V2. Calculate the average velocity. It is similar to the first problem. Second one, only average velocity you have to calculate. No data is given. Only average velocity to be calculated. So what is the total distance? First half and second half. Velocity V1, velocity V2. Let the total distance be x plus x. First half, second half. First half x, second half x. So 2x. Average velocity. Total time taken. Time also not given. C is equal to T1 plus T2. Time is distance by velocity. No, sir, I will take yes, sir. You can take yes also, you can take x also. Displacement, anything you can represent. Okay, next. Therefore, average velocity will be displacement by time. X1 by V1, X2 by V2, X1, X2, both are equal. So I can write 2x by x into 1 by V1 plus 1 by V2. X cancel 2 into V1 V2 by V1 plus. First problem we have done similar. So two different speed is given. Calculate the average velocity. Means this is the basic formula. First half one speed, second half one speed means it is easy to calculate. Okay, fine. Next problem. It is 2A. A cyclist moving on a circular track of radius 100 meters completes one revolution in 4 minutes. What is its average speed and average velocity in one full revolution? Radius 100 meters. You have to calculate average speed and average velocity. What are the data given? Distance. Speed means you want the distance. Circular motion, it should be 2 pi r. What is the radius given here? 100 meters. 2 pi into 100. So 200 pi. Speed is equal to distance by time. That is 200 pi. Time is 4 minutes. If you want the answer in terms of SI unit, convert into second and then write. No, sir, I want the answer what is given the data. You can write as it is. 55 meters per minute. In terms of second means per 6 by 60 out. Okay. Next. Velocity. Velocity is displacement by time. Displacement by time. Displacement is what? For one full revolution. Starting point and ending point is same. When you say starting point and ending point is same, displacement is zero. Because displacement is shortest distance traveled. Here both are equal. So displacement is zero. Therefore, velocity is zero after one full revolution. Whatever may be the time. Sir, I am doing 10 revolution. Any number of revolution you do, velocity is zero. Because displacement is starting point, ending point, shortest distance. Both are equal. So displacement is zero. So that is the difference between speed and velocity. Okay. Next, third problem. Car covers first half of the distance between the two places at a speed of 40 km per hour and the second half at 60 km per hour. What is the average speed of the car? Which is similar to the first and second problem. Average speed, when they have given two different distance, first half and second half, and they are asking you to calculate average speed or average velocity, directly we can use V average is equal to 2V1 V2 by V1 plus. How? Velocity is displacement by time taken. Displacement is 2x. Time taken is distance by velocity. Simplify, we will get this. Already we have done this, but now on a different concept. What are the values? 40 km per hour and 60 km per hour. V average is 2 into 40 into 60 by 40 plus 60. 80 into 60 by 100. Two zeros cancels. 48 km per hour. That is the average velocity. Okay. Next problem. A train moves with a speed of 30 km per hour in the first 15 minutes with another speed of 40 km per hour in the next 15 minutes. That time the speed is 60 km per hour in the last 30 minutes. So three different speeds they have given: 30 km per hour, 40 km per hour, 60 km per hour. Calculate the average speed of the train for this journey. Calculate the average speed. Average speed how to calculate? First calculate total distance traveled. Next total time taken. Average velocity. Total distance is d1 plus d2 plus d3. Three different distance. What is the distance here? Velocity into time. first distance, that is velocity or speed is 30 kilometer per hour in first 15 minutes. 30 kilometer per hour, first 15 minutes, that we are converting into hour by 60. Because this is given in kilometer per hour. So this is also to be converted per hour. One unit in per hour, another unit in minutes means you cannot do it. Either convert first one in terms of minutes or convert second one in terms of hours. We are converting the second one in terms of hour. Plus V2, second speed, 40 kilometer per hour. 40 into 15 by 60. Third, 60 kilometer per hour in next 30 minutes. These are the data given. So, total distance D is equal to 30 by 60 is 2 times. 15 by 2 is 7.5 plus 4 into 15, 60. 60 cancels. So, you will get 10. Cancels 30. So, 47.5 kilometers. Time, total time taken 15 minutes, 15 minutes, 30 minutes. 15 plus 15 plus 30. 1 hour. Total time is 1 hour. Therefore, average velocity, that's what you have to calculate. V average is equal to 47.5 kilometer by 1 hour. So 47.5 kilometer per hour. Fifth one. A car travels along a straight line for the first half time with the speed of 50 kilometer per hour and the second half time with the speed of 60 kilometer per hour. What is the average speed? Directly we can write first half 50, second half 60, 50 plus 60 by 2, 55 kilometer per hour. Straight. No, sir, I want to do with the formula. You can write. Average velocity is equal to S1 plus S2 by T. What is S1? Distance. Distance is velocity into time. Velocity is 50 kilometer per hour into time T1. Next is 60 kilometer per hour into time T2 by T. 50 into first half, that means T by 2. Next half, so T by 2 divided by average velocity. T cancels. 50 by 2, 25 plus 30. 55 kilometers per hour. Sixth problem. The displacement of a particle moving along x-axis is given by x is equal to 18t plus 5t square. X is equal to 18t plus 5t square. Okay. Calculate instantaneous velocity at t is equal to 2 seconds. First, instantaneous velocity. What is velocity? Rate of change of displacement. That is, you differentiate this equation. 18 plus 5t square. T square when you differentiate, you will get 2t. So 2 into 5, 10t. When you differentiate t with respect to t, the answer is 1. You are differentiating this displacement, so you are getting the velocity term. At t is equal to 2 seconds, velocity will be 18 plus 10 into 2, 20 plus 18, 38 meters per second. Second, average velocity between t is equal to 2 seconds and t is equal to 3 seconds. Average velocity x1 when t is equal to 2 seconds. 18 into 2 plus 5 into 2 square. 36 plus 5 into 4. 5 into 4 is 20. 56 meters. X2 when t is equal to 3 seconds. 18 into 3 plus 5 into 3 square. 54 plus 9 into 5, 45. 99 meters. Therefore, average velocity will be x2 minus x1 by t2 minus t1. Change in displacement by change in time taken. What is change in displacement? 99 minus 56 by 3 minus 2. 99 minus 56. 37 meters per second. Denominator is 1. So 37 meters per second. 99 minus 56. No, it should be 43. 43 meter per second. Third, calculate the acceleration. Acceleration is rate of change of velocity. D by dt of what velocity we have calculated? We have calculated velocity as 18 plus 10t. 18 plus 10t. That's what we have calculated. What is t value given? Calculate instantaneous acceleration. Instantaneous. At that moment. When you differentiate 18, it is a constant, it is 0. 18 into 2. Instantaneous. At that moment. When you differentiate this, you cannot substitute t is equal to 1 here. You have to differentiate. Differentiate t with respect to t. The answer is 1. So the answer is 10 meter per second square. This will become 0. This will become 10. dt by dt is 1 mass. So remaining is 10. 10 meter per second square is the acceleration. Okay. Fine. Next. Seventh one. Seventh problem. The velocity of the particle is given by the equation v is equal to 2t square plus 5 centimeter per second. Find the change in velocity of the particle during the time interval between t is equal to 2 seconds and t is equal to 4 seconds. You have to calculate change in velocity. Next, you have to calculate average acceleration during the same interval. And 3, instantaneous acceleration at t2 is equal to 4 seconds. One by one we will do. 3 things asked. First one, change in velocity, v1. What is the equation? 2t square plus 5. 2t square plus 5. When time is equal to 2 seconds. 2 into 4, 8 plus 5, 13 meters per second. Second, V2. What is V2? 4 seconds. At time T2 is equal to 4 seconds. 2 into 4 seconds. 4 square plus 5. 2 into 4 square, 16 plus 5. 32 plus 5, 37 meters per second. Therefore, change in velocity is equal to V2 minus V1, 37 minus 13, 24 meters per second. Correct? Second subdivision. Average acceleration. Average is change in velocity by change in time. Rate of change of velocity. What is change in velocity? 24. Just now we have calculated 24. By change in time, T2 minus T1. What is T2 minus T1? 2 seconds, 4 seconds. So 4 minus 24 by 2, 12 meters per second. Correct? 3 subdivisions we have in this problem. The displacement x of a particle along x-axis is given by x is equal to 3 plus 8t plus 7t square. 3 plus 8t plus 7t square. You have to calculate the velocity and acceleration at t is equal to 2 seconds. When t is equal to 2 seconds, velocity is rate of change of displacement. Differentiate this equation. This will become 0. This will become 8 plus t square is 2t. So you will get 14t. That is, at t is equal to 2 seconds. What will happen? 8 plus 14 into 2. 28 plus 8. 36 meters per second. 36 meters per second. Acceleration, rate of change of velocity, dv by dt. You differentiate this. This will become 0. This will become 14. So 14 meters per second square. The distance traveled by a particle moving along a straight line is given by x is equal to 180t plus 50t square. Calculate the initial velocity, the velocity at the end of 4 seconds, and the acceleration of the particle. First, you differentiate initial velocity. V is equal to dx by dt. Differentiate, this will become 180 plus 100t. Initial velocity at t is equal to 0. Initial velocity means t is equal to 0. At time t is equal to 0, initial velocity, initial acceleration, like that, and all question will be asked. So at E is equal to 0, V is equal to 180 meters per second. Second, you have to calculate velocity at the end of 4 seconds. V dash is equal to V is 180 plus 100t. 180 plus 100 into 4 at the end of 4 seconds. That is the question. So I will write 180 plus 400, 580 meters. Next, calculate the acceleration. Rate of change of velocity is called acceleration. A is equal to dv by dt. When you differentiate, this will become 0, this will become 100 meters per second. Straight. Okay, good. Next. Yeah, jet plane starts from rest with an acceleration of 3 meters per second square and makes a run for 35 seconds before taking off. What is the minimum length of the runway and what is the velocity of the jet at takeoff? Jet plane starts from rest. You have to calculate what is the minimum length and what is the velocity at the taking off time. Okay. Acceleration 3 meters per second square. Time 35 seconds. Acceleration. What is acceleration given? 3 meters per second square. And time taken is 35 seconds. Distance is equal to ut plus half at square. At the time of starting, initial velocity is 0. So this will become 0 plus half at square. 3 into t square is 35 square. 35 into 35 into 3 divided by 2. When you simplify, you are getting 1837.5 meters. This is the minimum length of the runway. Next, we have to calculate the velocity. What is final velocity formula? V is equal to u plus at. At the time of starting, u is equal to 0. What is acceleration? 3. Time taken 35. 105 meters per second. Straight problem. Then 11th one. An electron traveling with the speed of 5 into 10 power 3 meter per second pass through an electric field with an acceleration of 10 power 12 meter per second square. How long it will take for the electron to double its speed? What will be the distance covered by the electron in this time? How long will it take for the electron to double its speed? First time you have to calculate. Velocity is displacement by time. Time is equal to displacement by velocity. That is one equation. Then another equation of motion we can use. V is equal to u plus at. At is equal to v minus u. T is equal to v minus u by a. What is final velocity? What is initial velocity? double its speed. Double its speed means this is 2u minus u by a. That is u by a. What is velocity given, man? 5 into 10 power 3 by acceleration is 10 power 12 meter per second square. Simplify, you will get 5 into 10 power minus 9 seconds. 5 nanoseconds. It takes to double its speed. First part. Second, what to be calculated? Distance. What is distance formula? S is equal to ut plus half at square. What is u? 5 into 10 power 3 into time taken, 5 into 10 power minus 9 plus half. What is acceleration? 10 power 12 into t square. T square is 25 into 10 power 6. S is equal to, simplify this, you are getting 3.75 into 10 power minus 5 meters. Straight substitution. Okay. 12th problem. A race car accelerates on a straight road from rest to speed of 180 km per hour in 25 seconds. Assuming uniform acceleration of the car throughout, find the distance covered in this time. Velocity is given 180 km per hour. Time is given 25 seconds. Uniform acceleration, distance you have to calculate. First velocity 180 km per hour. Convert into meter per second into 5 by 18, 10, 50 meters per second. What is acceleration? Change in velocity by time. 50 minus starting from rest. Anywhere the word starting from rest means initial velocity u is equal to 0. Please keep it in mind. 50 minus 0. What is the time taken here? 25 seconds. 2 meter per second square. Next, distance you have to calculate. Therefore, distance S is equal to ut plus half at. Initial speed 0 plus half a is 2 t square. What is t given? 25. So 25 square. Cancel 625 meters. A bullet traveling with a velocity of 16 meter per second penetrates a tree trunk and comes to rest in 0.4 minutes. Find the time taken during the retardation. Comes to rest in 0.4 meters. Find the time taken. Time taken only you have to calculate. Again, equate the motion. V square is equal to U square plus 2AS. So first calculate acceleration from this, then we can calculate the time taken. V square. What is velocity given? Final velocity is 0 is equal to initial velocity is 16 meter per second. 16 square plus 2 2as 2a into 0.4 meters. So acceleration is, it is minus here. Why minus? During the retardation, that is the question. Retardation means negative acceleration. So minus sign we are putting. So minus 0 is equal to 256 minus 2a, 2 into 0.4, 0.8a. 0.8a is equal to 2. A is 256 by 320 meter per second square. Acceleration, retardation is minus sign. That's all. 320. Minus sign means retardation. Fine, next. 14th problem. The reaction time for an automobile driver in 0.6 seconds. Automobile can be decelerated at 5 meter per second square. Calculate the total distance traveled coming to a stop with an initial velocity of 30 km per hour. Accelerated 5 meter per second square. Calculate the total distance, initial velocity 30 km per hour. Distance d or s, whatever it is, s is equal to velocity into time. What is the velocity given? 30 km per hour. 30 into 5 by 18 into time taken 0.6 seconds. This is 5 times, this is 3 times, 25 by 3. 25 into 0.6, 15 by 3, 5 meters. When accelerated, what will happen? V square is equal to u square plus 2as. Final velocity is 0. So 0 is equal to velocity 30 km per hour, 30 into 5 by 18 plus 2as, 2 into acceleration. Here it is retardation, minus 5. Stop within 5 meters. No, decelerated 5 meter per second square. That is the question. So minus 5 into s you have to calculate. It should be square. So square it 625 by 900. 900. This 10 also will go here. Okay. Simplify this. You are getting the answer 6.94 meters. Therefore, total distance traveled s is equal to s1 plus s2. What is previous value? 5 meters. And this one 6.94 meters. 11.94 meters overall. Okay. My next 15th problem. A stone is dropped from a balloon rising upwards with a velocity of 16 meters per second. The stone reaches the ground in 4 seconds. Calculate the height of the balloon when the stone is dropped. S is equal to ut plus half at square. Basic formula. Dropped means A is equal to G. Here S is equal to the height, A is equal to G, U is equal to 0. Now, initial velocity given What is the value? 16 meter per second. Implies S is equal to H U into what is the time taken? 4 seconds. This is 16 into 4 plus half G 9.8 into T square. 4 seconds is 16. Simplify this. You are getting 14.4 meters. Straight round. Correct, ma? So equations of motion, any equation, vertically upward or downward, replace A is equal to plus G or A is equal to minus G. And in general, where to use which equation? 3 equations we have. Without time means V square is equal to U square plus 2AS we can use. Basic means A is equal to V minus U by T or S is equal to UT plus of it square if there is no time involved. Third, if time involved means second. Next, 16th problem. A car A moving at a speed of 10 meters per second on a straight road is ahead of car B moving at the same direction at 6 meters per second. Find the velocity of A relative to B and vice versa. Velocity of the first, velocity of the second. 10 meters per second, 6 meters per second. Your aim is to calculate velocity of A with respect to B. VAB 10 minus 6, 4 meters per second. Straight. So this is positive velocity. Resultant velocity is positive. What is the meaning? A is moving faster, B is moving slower. So when both the cars are moving, A crosses B. Driver of B is seeing the car A moving. He is lagging behind because his velocity is only 6 meters per second. So positive velocity. VBA, that is VB minus VA. What is VB? 6 minus 10, minus 4 meters per second. Negative velocity is indicating body B moving slowly, body A is moving. So while crossing B, he is turning towards the second car and then moving. First VA and VB starting at the same time. After reaching some distance, he is overtaking because his speed is more, VA speed is more. So he is turning back and seeing second car, which is lagging behind. So minus sign here. Next, 17. A car A is moving with a speed of 60 km per hour and car B is moving with a speed of 75 km per hour along parallel straight paths starting from the same point. What is the position of car A with respect to B after 20 minutes? Relative speed first we'll calculate. Relative speed. What are the data given? 60 and 75. So 60 minus 75 minus 15 kilometer per hour. Next. What is the distance of A from B? Distance is equal to velocity into time. What is velocity given here? After 20 minutes. So minus 15 after 20 minutes means 20 by 60. You have to convert into hour. 4 times minus 5 meters. Sorry, kilometer. Sir, how minus by kilometer will come? The person is not moving in the opposite direction. Why it is coming minus? When you see the problem, what is the position of car A with respect to car B? After this 20 minutes time, car A is ahead of car B and car B is here. The distance between the two is minus 5 kilometers. Because with respect to car A you are traveling, car B is lagging behind. So minus. Fine 18. Two buses start simultaneously towards each other from towns A and B, which are 480 km apart. First bus takes 8 hours to travel from A to B. Second bus to travel 12 hours from B to A. Determine when and where the buses will meet. Okay. First bus velocity. What is the velocity value, ma? First one. 480 kilometer. It takes 8 hours. 480 by 8. 60 kilometer per hour. Next, return bus. It takes 12 hours for the same distance. 480 by 12. 40 kilometers per hour. Okay. Now, what is to be calculated? At what time these two buses will meet? Two buses are moving in the opposite direction, man. They are moving in opposite direction. So when it is moving in opposite direction, definitely at one particular time they have to meet. What is the time taken? Only question. What is displacement? S is equal to velocity into time plus V2 into T. What is displacement given here? 480 kilometers. 480. First velocity 60 kilometer per hour into T plus second velocity 40 kilometer per hour into T. 60T plus 40T, 100T is equal to 480. T is equal to 480 by 100, 4.8 seconds. Sorry, 4.8 hours. So, after 4.8 hours, these two buses will meet at a particular point. So, distance from A, distance from A will be velocity into time. What is velocity? 60. Time taken is 4.8 kilometer per hour. This is 60. Calculate 288 kilometer. So at 288 kilometer, these two buses will meet each other. Excellent problem. Okay, Amma? Thank you. These are the problems related with motion of bodies in straight line. Very simple concepts, basic concepts we have explained. Okay. Thank you. We'll continue.